Okay, and we should be live. Let me just check the audio, as always. Hello, 1, 2. Yeah, okay, we're all good. Right, let's get on with this then. Let's continue. Seems like we're all good for volume. Let me just check that. Yeah. Okay, right. Let's continue then. So where were we? We were on conditional operators. Hang on a second. Yeah, conditional operators. Okay. Right. Where were we? Yeah, so conditional operators are basically another way to be able to write um, uh, if statements using WTF as a acronym basically. So what is the condition we're looking at for? If it's true, then we run it, and if it's false, then we run that conditional operator as part of an expression. So since the conditional operator is evaluated as part of a an expression, it can be used anywhere an expression is accepted. For example, we've got a constant expression Boolean with an identifier of in big classroom and then being false. Then we've got a constant expression of int class size in big classroom, and if it's true, i.e. if the big classroom is true, then it's 30, and then if it's false, then it's 20. The class size is class size. If there is no direct if-else replacement for this, you might think of something like this. However, you'll get a undefined error on class size. If you wanted to do that, you need to do something like this. Using brackets in the conditional operator. Because C++ prioritizes the evaluation of most operators above the evaluation of conditional, it's quite easy to write an expression using the conditional operator that doesn't evaluate as accepted. So you got an integer of a identify a type of integer x with an and then an identifier of x with a initializer of 2. Then you got that for y, and then z. So if So if 10 minus x is greater than y, then x is true. We do x. Else y. You might expect. Okay. Here's another example. But let's just show that as an example. So I'll do include input output stream. Then I'll do our return type of integer, main, and then in our body we'll do the type of int x initialized, or initialized as 2, int y initialized as 1, and then our conditional operator int z 10 minus x. So if 10 minus x is greater than y, then we do x, else y. And then we'll do a standard character output of z. Then we'll simply return. So if we do that, let me just restore the build again. Get rid of that. And we get 2. Here's another example. So we have a data type of integer, an identifier of x with initialized as 2. So if x is less than 2, if x is less than 0, then it's negative, or else it's non-negative. So this should produce non-negative. Let's just prove that. Include input output stream, return type of integer for our main, and in our body an integer of x initialized as 2. Then we'll have a standard character output of x. If x is less than 0, then it will be not negative, and then if else if that's not the case, non-negative. I'm getting errors. Why is that? Oh, it's just saying the expression is unused. What if we did that? Does it always produce that? Yeah, it does. Okay, but we know it runs, so that's fine. So what was the difference between that? Oh, because we did int z. Okay, that's okay. I'm happy with that. To avoid such. So like, oh, that's a common mistake, yeah. So you would do that. Yeah. Okay. That's fine. I'm happy with that. So when writing a conditional operator, wrap said conditional operator in brackets, such as this. Okay. Yeah. So the best practice is to parenthesize. The type of expressions must match or be convertible. Also, the type of the expressions must match or at least be convertible. I.e., the type of the second and third, aka this and this operand must match. And the compiler must be able to find one way of converting. Okay. For example, standard character output true if and true, as we know, is 1, and then because we know true is can also be defined as 1 and false is 0, that's okay because true can be converted into an integer, and plus our operands match. That's okay as well. 1 will just be converted into a double implicitly, and this will provide unassigned because it's outside of the range. Okay. So when should you use when to use a and then the conditional operator is most useful. When initializing an object with 2 values. assigning one or two values to an object, passing one of two values into a function, returning one or two values from a function, and finally printing one or two values. Now, as I was going to say, the sometimes it can be hard to read, and depending on your style, you can use if, else, or you can use conditional. Relational operators and floating point comparisons. Okay. Relational operators allow for the comparison of two values. There are 6 of them, and we've already covered most of them whilst doing these lessons. So let me just copy and paste that. So greater than, less than, and then we'll do a symbol, and we'll do that. We'll do that. I should do that because then we'll do that. Then we'll do that, and then we'll do that, and then the form. Form is that. The form is that. The form is that. Fairly straightforward. And then the operation is all these. Cool. Yeah, as he said, we've already seen most of these work. So here we got a enter an integer. We're creating the integer with no initializer. We're then doing a standard character output and allowing the user to enter. And then we're doing it again. If x is equal to y, it equals. If x does not equal y, does not equal. If x is greater than y, x is greater than. If x is less than y, less than. If it's greater or equal to, it's greater or equal to. And then if it's less than or equal to, it's less than or equal to. Feel free to run this code. I'm personally not going to because we've done it before in previous examples. Yeah. Boolean conditional values. By default condition. So many programs would write this. This is redundant as the equals true doesn't actually add any value to the condition. We should write B1. Similarly, the following is written as not B1. Yes. For example, when comparing booleans, it is better to write true as this rather than and false as this, if not B1. rather than um, rather than if b1 equals false. Cool. Don't add unnecessary conditions, it makes it hard to read. So comparison of calculated floating points values can be problematic. Consider the following. So we've got a constant expression double. Now remember, constant expressions will be evaluated at compile time. So we got a double d1, 100 minus 99.9, and then the same d2, 10 minus 9.9. So if d1 is equal to d2, we do that. Else if d1 is greater than d2, we do that. Else if d1 is less than d2, we do that. Variables, and it can cause errors due to rounding errors. Floating points less than or greater than. When the less than and greater than are used with floating points, they produce a reliable answer. So they will produce a reliable answer in most cases when the value of the operands is not similar. However, if the value... So basically, if the values... So if the values of floating points in a conditional operator or a standard if statement are similar, then this is where errors can begin to creep in. For example, Space Invaders, when you determine whether you want okay. Yeah, so probably best used to avoid is to avoid using operator and operator does not equal to compare floating point values if there is any chance of them being to compare point values if there is any chance of them being of those values having been calculated. Okay. It is safe to compare floating point literals. So it is more safer to compare floating point literals, as these have obviously not been calculated as they are literals. Makes sense? Okay. Yeah, we'll go through this. Why not? It'll only help us. So how can we reasonably compare floating point operands? The most common method of doing floating point involves using a function that looks to see if they're almost close. The value of almost close is called an epsilon. Epsilon is generally defined as a small positive number with the scientific notation of E1, E minus 8. Now developers often try to write their own close enough function like this. So we're including C math, and we're going to be using the standard absolute. So it would be something like this. So include C math for standard absolute. And then we'll epsilon is an absolute value. So a bool prox equal abs, and then we'll have a double of A, a double of B, and then a double of ABS epsilon. And then within the body, if the distance between A and B is less than or equal to absolute epsilon, they are close enough. So return standard ABS, and then we're doing the float A minus B, and then we're doing if it's less than or equal to ABS epsilon, and that should be double. Okay. Standard ABS is a function in maths header that returns an absolute value. So standard ABS. but it cannot always be useful. So on the left side of the operator, uh, I think I'm gonna leave this for now and perhaps come back to it. I think I'll get rid of this for now. I don't think I'm at that level. Advanced, I'm not at that level yet. Perhaps we can come back to it. Okay, we'll move on to logical operators. If you would like to cover all this, we are on lesson 6.7, and I've basically stopped here. So if you would like to read it, feel free to read it. But perhaps when I do a project and I need floating point comparisons, I will come back to this, but not for now. Okay. So logical operators. So C++ has three logical operators: not, and, or. Example, if it's not equal to x, if x and y are true, if x or y are true or false. Or true, sorry. So the symbol is that, the symbol is those two, and the symbol is those two. You will find that in the symbol, the symbols are essentially the same across all languages. It seems it's universally accepted that these are probably the best, probably because they've been used so often. So you'll see it in JavaScript, you'll see it in Swift, you'll see it in a bunch of other stuff. A logic not. So it's to check if x is not true. True if x is false, false if x is true. It's basically the reverse. It may seem tricky at first, but you will eventually get used to it as you use it more and more. I found at first when I was doing it and I saw the exclamation mark, I would always get confused. But eventually, you just keep using it, and you'll get it eventually. So, for example, here, boolean too large, x is greater than 100. If not too large, i.e., if x is less than 100, do something else. If x is more than 100, do something else. One other thing to be aware of. Yeah, the correct way to do that is in a bracket. So the best practice for logic not, which is this symbol, is to use a closed bracket or parentheses if you're American, like this. Okay, logic OR. The logic OR operator is used to test whether their conditions are the same. So for example, here we have a standard character output and we're entering a number. We're initializing the number as empty. We're then allowing the user to enter the value. And then if the value here is exactly equal to 0, or the value, i.e. this one, is exactly equal to 1, you picked 1 or 0. Else you did not pick 1 or 0. Let's just prove that and get used to using OR operators in C++. So we'll include input-output stream. Then we'll do a return type of integer for our main function. Then within the main function, we will do standard character output, enter a number. Then we'll do an unassigned integer, and then we'll allow the user to enter the value. Sorry, x, not the value, because I've already defined x, whereas in here they did value. Then if x is exactly equal to 0, or x is exactly equal to 1, then we will do the standard character output of you picked 0 or 1 with a line break. And then, what have I done wrong there? No, nothing. We don't actually need the parentheses or the squiggly brackets, curly brackets. Else, standard character output, you did not pick 0 or 1, and then that standard character, no, fine, return 0. So then what we do is we will just try this. So for example, if we did 0, you picked 1 or 0. We run it again. If we pick 10, you did not pick 1 or 0. Cool. In this case, we use a logic OR and also the equals that we learned in the previous lesson. Yeah, and you need to make sure that you include the identifier or the variable here. Yeah. The logic AND. So again here we're entering a value, and then we're creating the value with initializer with the initializer being empty, because we're allowing the user to enter the value here. So if value is greater than 10 and value is less than 20, your value is between 10 and 20. Else your value is not between 10 and 20. And again, for practice, let's do include input output stream, return type of main, and then we'll do standard character output, enter a number, and then we'll do int value uninitialized. Remember, if it is empty, then it is uninitialized. So then we do standard character input, and we allow the user to enter the value. and then if value is greater than 10 and value is less than 20, we do the standard character output of your value is between 10 and 20. Else, standard character output, your value is not between 10 and 20. So let's just test that. Clear my terminal, run it, and then enter a value of 8. Oh, sorry, yeah, I thought it was between 1 and 10. Yeah, your value is not between 10 and 20. And then we'll run it again. And we'll do 18. Your value is between 10 and 20. Cool. That makes sense. So for me, I'm not going to make any notes, but if you'd like to make notes on the AND operator, feel free to do so. Yeah, feel free to do so. Okay. Yeah, so you can have many and or operators as well. Feel free to use as many as you would like to. You can also use and you can use or and operators as well. You know what? Okay, right. Mixing and and ors logic. Make sure you put the and in parentheses. So let me just get that. Let me put that there. So we know from previous times that our logic operator of and has a higher precedence than or. No, sorry, no, it doesn't. They have the same. Yeah, they do, sorry. Than or. So it is better to put your and operator in brackets, such as value 1 and value 2 or value 3 and value 4. So the best practice when mixing when mixing and or operators is to rep the operators as you intend for the program to use them. No, I don't need to copy that because I just wrote that out. So not x and y is equivalent to not x or y. Okay. De Morgan's law. Interesting. So De Morgan's law tells us how the logic not should be used when using and or operators. So if you were to write x, not x and y, this should be written as not x or not y. So basically flipping it. So you're going from and to or, and then if you're doing the same, you're going from or to and. Not x, not y. And then if it is not x or y, this should be written as not x and not y. In other words, you flip the logic exactly. Okay. Where is the logic exclusive or XOR operator? So you can, it seems, use and or not words from the keywords. But I personally, I would prefer to use this rather than and or. But if you'd like to use and or, feel free to do so. But personally, I think this is much cleaner than this. Okay. Evaluate the following expressions. Note in the following answers, we explain our work by showing a steps taken, set separated by symbol. Okay. So, So if it's true and true, or false. So this would be 1 and 1 or 0. True and true or false turns into true. So it would be false or true, and then true. Evaluate the following. So if 1 is less than 2, or 3 does not equal 3, then one less than 2 is true. So false and true turns into false, and true, which turns into false. So you have false or true, which turns into false and true. False? No, false and true. So 5 less than 6. So if 5 is 5 less than 6? Yes, so that turns into true. Or is 4 greater than 3? So that turns into true. So this turns into true then, possibly. And is 7 greater than 8? 7 is not greater than 8. So this turns into true, and this turns into false. So the result is false. Okay. Okay. We wrote an expression that looked like this. Rewrite the function using operator not and operator equals. Okay, first of all, what we'll do is we'll write out the function, include input output stream, boolean is even, int x, and then if x remainder 2 is equal to 0, 2 divides even, which means it must be an even number. So we return x divisible, x remainder 2 is equal to 0. So then we do a return type of integer for our main function. Then we do a standard character output of enter an integer. Then we do an uninitialized integer of x. Then we do a standard character input of x. If is even, then standard character output of x is even. Else standard character output of x is not or is odd. So rewrite this using so if x is equal, so like this, right? Is that right? Sorry, no. Oh, instead of, my bad. So that means surely we just need to do is, so if we were to, do that, then that means we return, so is even, so like this. So we're returning x modulus, x remainder 2 is not equal to 0. So that means surely we'd rewrite this to odd, and then we'll rewrite this to odd, and then this will be odd, and this will be even. Is that the correct way to do it? Let's have a look. So we'll run it, enter an integer, we'll do 3. 3 is odd. Enter an integer, we'll do 100. 100 is even. Is that, so we've changed it to odd, and if the remainder is not equal to 2, if x remainder 2 is not 0, yeah. Let's have a look. Okay, he's done that. So if it's not that, so he's basically just gotten rid of that. Okay. Okay. I think we'll take a quick break here, and we'll see where we. I just want to take a quick break, and then we'll finish with the chapter summary. So I'll be back in a minute. Right, where were we? How are we looking on the volume? Still good? Let me just check. Yeah, we're still good. Okay, let's continue then. So we're on the summary now. Okay. So we learned to always use parentheses or brackets to distinguish between the logic operators, and it can really help. And we can use the modulo operator, aka the percentage sign, to find the remainder between when dividing two values. And we can use the increment, and remember we can use prefix or postfix. And postfix can be quite complicated to remember. We can also use a comma operator to compress multiple statements into one, but remember that the comma operator only outputs the furthest to the right, furthest to the right of the operator. We just did the conditional operator a few minutes ago. Right, quiz time. Okay, let's have a go. Complete the following program. Write a function to get quantity phrase here. Write a function to get apples pluralized here. So let's get rid of this. We'll do include input output stream as always. We'll do our return main function type with a return type of integer. We'll do a constant expression of int Mary apples, and we're initializing it with 3. Then we're doing a output of Mary has get quantity Mary apples, and then get apples pluralized Mary apples. And then we'll do a full stop and a line break. For now, I'm just going to comment this out just to get rid of the errors. So we could use this, but I'm going to do the if 0 just to get used to being in the habit of it. Then we do standard character output of how many apples do you have? Space. Then we're allowing the user to enter the number of apples and then uninitialize it of 0. Uninitialize, sorry. Standard character input of number of apples, and then standard character output of you have, and then get quantity phrase, and then that'd be num apples, and then a space, and then get apples pluralized, and then the parameter of num apples. And then we'll do a full stop. And then, as always, we'll return 0 in our main function. And as above, we'll do if 0, and then we'll do end. we'll do end if. Okay. We'll do end if. Cool, so that's gotten rid of that. Why are we... Oh, if 0. That's fine. So we need a function for get quantity. We've already seen that we're passing something in, so this will need a parameter at least. This will need a param. So for now we did get quantity phase and then int num, and then in the body. And then we also need a get apples pluralized. For now we'll do int, and we'll do int of num. Okay, so or do we want a void? Is it better to have a void and not return anything? Possibly. So if we did void for both of them, then if we did so get quantity phrase and get quantity so I don't think we want to change that. So surely we just would do standard character output standard character output of hang on a minute, get quantity phrase so in that case we will want to use an if statement because we're lumping them all together. No, it can't be void because we're going to be putting it in a standard character output. And we only want one function. So we'll do int. We'll return these back to int. Get quantity phrase. Integer. To take a single integer parameter, descriptor. Otherwise, apple. So if num is equal to 1, we will do a standard character output. No, we will return perhaps standard character output apples else sorry, if equals 1 apple else standard character output apples. So in that case we need a semicolon. So in that case surely what we're doing there is, so if the number is equal to 1 then it's a single apple. Else, if the number is not equal to 1, then it's apples. I think we could turn this into a operator, conditional operator. Yeah, exactly. So let me just comment this out. And then end if. So we would return, we would do num. So what are we looking for? We're looking for num1. And if num1 is true, then we do standard character output apple. And we'll wrap all of this in its own outer brackets. Else, we do a standard character output of apples. Yeah? So like that. So that's that. Get the quantity phrase. Should take in a single parameter representing a quant from the font 0 equals negative. So it should take a single. So then we do an if statement. And this is going to be using the so if num is less than or equal, or is less than 0, then we return standard character output of negative. Then else if num is equal to 0, we do standard character output. That should be a semicolon there. We do a standard character output of no apple, i.e. she has no apple. Else if, see, because we're using else if here, yeah, I don't think it would be logical to use a conditional operator. So else if num equals 1, we do a standard character output of, no, it shouldn't be equals, it should be that. 1. So a single, and then it would be a single apple. Semicolon. Else if num equals 2, we'll do a standard character output of a couple of. Else if num equals 3, and then that's why we're producing the error. So standard character output a few, and then else, because we're checking if it's less than 0, which means we've covered negative, and then we're checking everything else. And then if all of these are not true, i.e. if it's not negative and it's not between 1 and 3, then it must be greater than 3, and then standard character output many. So then and then we need semicolon as always when it comes to this. So then what we need to do is we need to let me just get rid of the terminal for now. So then we need to implement this. So surely we just get rid of this, and then that'll bring that. And then if we get rid of this, let's see how we print. That's probably easier to read. So if we run that, we have an error here. That's why, because this needs to be double quotes. Double quotes. Let me run that again. So that should have been equals, my bad. That should be exactly equal to. Let me run that again. And then we have an error on line 20 and 25. Oh, because we need to return num, as always. And then here we need to return num. And those should be the errors gone. Cool, nice. So let me just clear that and we'll run it again. Mary has a few apples. Mary has a few 3 apples. So what we actually want is how many apples do you have? I have 10. You have many 10. So we're getting the output correct, but we're getting few and then 3. So that means we need to does that mean we need to convert this into a string that calls this Mary has, and then we're getting this so what if we did const expression no we did this as a constant expression int 64 would that make a difference? Mary, we're still getting the same. What about if we got rid of that for now? We ran it again, but we don't have any Mary apples. So what we need to do then is we need to create an integer for what if we just did that and then we got rid of that for now. Then we ran the code again. Mary has no apples, no apples. See, the issue is then Okay, so we do. I had a feeling we needed to return a string. So we need to use static cast, or we need to use string. Uh, so let's call in include standard include the string header, and then do we in here say we need to pass in the string? The string would either go here or it would go here. I think string view would be better here, or perhaps string view would be better here. Oh, then if we did const expression string view, standard string view, would that work? Then we would need to turn this into a string, into a standard string view, and then it would be num, right? Or am I? Yeah, I feel like I'm messing up somewhere. Yeah, I am. Is it because I'm not including string view? No. Unless the string view needs to go in the unless the string view goes in here, standard string view. But this needs to be a standard string. No, I think int and then a standard string of integer number. And then are we converting it to a static cast int num? I feel like this is getting way too complicated. Let's have a look. Okay, so standard string view goes here first. As I had, did I have that initially? Let's have a look and see if I'm right or I'm just lying. So I did, but I didn't need the constant expression. That way we can then get rid of this. Return many. Okay. That's where I was going wrong. And then so I needed to return so if we run that, Mary has no many apples. So what we actually needed to do was we needed to return all of these, and we didn't need the standard. We didn't need all these. standard character outputs. Because we weren't we were not in a void function, so we can return. Else, and we can get rid of that. Then if we ran the code again, Mary has no apples. So then here, would we do also an std string view? Because we're getting a number here. So standard string view so here we would get rid of this and we would return, and we would get rid of this and return, right? No, unless you put it in brackets perhaps, but then you're still getting that error of return. Expected an expression. If we return that back, but then we're not returning anything here. So if we cleared the terminal, no. So we need to return num still. Perhaps this is where we would use static cast, no? Static cast, and we want to return what do we want to return? We want to return, well, the expression will be num, and we want to turn an integer of num into a standard string view. No, we don't. Oh, char, sorry. Maybe that is the correct way. Char. Let's get rid of that. We put the return there. Stupid. So we get that, we've removed that. And then if we return this, then we get rid of the outer brackets. Return num1. We don't need this anymore because we're returning. Perhaps. Is that why? Yes. Okay. So when using standard string view, it seems we don't actually need to use standard character output, we can just use return within our function. Is that because it's a constant expression? Possibly. So I'm just going to run that again. Mary has a few apples because she has 3. I have 10 apples, so I should have many. You have many apples. So if you, hang on, let me just search Google. If using standard string view in C++ in a function, why do we use return and not standard character output? But that's exactly what we were on. Okay, so the standard string view passes in the type of character and allows us to have strings, which means that no, I understand now. So we are getting the string view. Because so the return type. So let me just make a comment of this. So the return type is standard string view. The return type is standard string view, which means we need to return a string. Hence why the logic or if statement is using return rather than standard character output. and then the same again here. So the return type for get apples pluralize is a string view. So therefore we need to return a string value back and not an integer like we would with if the function was had a return had a return type of int. Okay. Yeah, because we need to return the value type, and the value is a string. Yeah, see, there you go. No, my bad. I thought that said return. Uh, so it needs to return a boolean. Um, okay, this is a very useful website. cppreference.com. I'll make a note of that in the future as to what to use. Okay. I just want to make a note of that. Then I want to do this. Then I want to do that. And then I want to do operators quiz question. Okay. Nice. So what we'll do now, so that's chapter 6 done. That's an optional chapter, so I am gonna skip over this, but if you would like to go over it, I might go over that in another live stream or just off stream. So what we'll do now is we'll do scope, duration, and linkage. We've covered a bit of scope. We've covered that was linkers, and duration, I assume how long it lasts, i.e. within the square brackets of the body. So what we're going to do now is we're going to go back here, scroll back up here, and we're going to do 11 scope, duration, and linkage. And then we will scroll down here. We'll do this. I'll do that. And what I just want to do now is save or enter into the Git repository part 1. And it was finishing off operators. And what did we do? We did operators, we did conditional operators, we also did when to use them. We did floating points and the issue of using them with greater than or equal, less than. We did and other relational operators. We did relational operators. We did logic operators, logical operators. We did De Morgan's law, and then that was it. Tutto bene, and today's date is the 10th of August, 2026. Cool. So that's that. Now we're moving on to scope and linkage. I'm just going to take a quick break here, and I'll be back, and we can continue with compound statements next. Okay. Okay, and we're back. We're still good on the stream. Let's just have a look. Audio. Yeah, we're still good. Cool. Right, let's continue. Okay. So, compound statement blocks. So, a compound statement is a group of 0 or more statements that are treated by the compiler as if it were a single statement. Okay. And I just want to check my audio. Still good? Yeah, cool. No, not that. I want compound statements. So a compound statement aka a block statement statement is a group of 0 or more statements treated by the compiler as if it were a single statement. Just give me a second, I'll be back in a minute. Okay. Right. So blocks begin with this. So the body basically. No semicolon is needed, aka the end of the function. Start of the block, end of the block. Yes, as we learned in one of the first lessons, it's best not to do nested blocks. Using blocks to execute multiple statements conditionally. So if value is greater than or equal to 0, we run this code. Else, we run this code. Makes sense. Because previously, when writing our if statements, we haven't been No, I wanted to save this. We haven't been using blocks for the body. Typically, if you are writing an if statement, um, or a statement that may require a block or a body, and it's one line, in most languages, you're allowed to get away with not writing the curly brackets. And then it's possible to do if nested levels, i.e., if a nested if statement within an if statement. So if the value is greater than 0, if value divisible remainder 2 is equal to 0, then we do this. Then we do else. Then we do else, and then that. Yeah. Okay. Um, okay. User defined namespaces and scope resolution operator. I went through that quite quickly, as that's fairly simple for me. And if you've been following along, you've been using blocks for your functions quite often. Naming collisions. So a naming collision occurs when two identical identifiers are introduced in the same scope, and the compiler cannot differentiate. So we got in foo CPP, i.e. in foo CPP file, we did do something, and in goo we have do something as well, and then we're calling, or we're doing a forward declaration. So remember, a function is a definition, but a forward declaration is a declaration. A function is a definition and a declaration, but a forward declaration is just a declaration. So when we're calling do something, we don't know if we're calling do something from goo or foo. Which can cause potential errors. Exactly. C++ allows us to define our own namespace using namespace identifier, namespace keyword. Namespaces that you create in your own program are called user-defined namespaces. Okay. I'll copy the notes, but I want to do the syntax myself. Okay. We start namespace keyword. We start with the namespace keyword, and then the identifier, and then the body. So, for example, in foo, we recommend using kernel. So, for example, here, namespace foo, do something, namespace goo, do something, and then in main, we're doing here, but we're still getting a collision. So we would therefore you would just do using namespace goo and then int define something would be okay. Ah, okay, you do it like that. Accessing a namespace with a scope resolution operator. I would have thought you would have. No, okay. Because when you use, when doing this previously, i.e., accessing string view, i.e., not having to do std string view or std, you could do using namespace and then std. That way you wouldn't need standard string, and you can get rid of that, and that would still work, right? He says with a semicolon. Yeah. So I would have thought surely you could just do using namespace, and then it would be foo, even though foo doesn't exist at the moment. That's what I would have thought you could do. But so scope resolution operator. For example, and then let's get rid of this because we've made a copy, have we? Yeah, we did. Cool. Get rid of this. We'll do include input output stream. Then we'll do our namespace foo. Then we'll do int do something int x int y, and then that will return x plus y, and then semicolon obviously, and then we do namespace goo, and then that again will do the same thing of int do something something int x, int y, and then that will then do return x plus y. Then our return type of integer from main, and then we'll do standard character output. And now we're going to call the namespace of foo and do something. So foo, using the scope resolution operator. Scope resolution operator. Foo, and then as you can see there, it appears. Do something, and we'll do 1 plus 1. And then we will return 0. And you see we don't get any errors there. So let me just build it again. No errors. Cool. Run it. And we get 2. Nice. We'll just also add a line break to make it neater. Yeah. And then if you wanted goo, you could do goo. Cool. He did minus, so I'll just do minus. And then you'll see we'll get 0. It allows us to explicitly pick the namespace we want. The scope operator allows us to explicitly pick the namespace we want. For example, this. Cool. Using the scope resolution operator with no name prefix. That way it's global. Okay. With no name prefix. So standard character output. Hello. And then in our int, we will first of all call foo with a scope resolution print, and then the global print. This is essentially the same as calling the void print function, and then we'll return 0. Let's just run that just to see. Hello, hello. Hello, global. Hello, foo. Run that. Hello, foo. Hello, global. Cool. Nice. Identify resolution from within the namespace. If the identifier inside a namespace is used and no scope resolution is provided, the compiler will try to find a matching declaration in the same namespace. If no identifier is found, the compiler will then check each containing namespace in the sequence to see if a match is found, with a global namespace being checked last. So that means so that's all about nesting. So print is the global namespace. Jesus Christ. And then we're calling, we're creating void print again in our namespace foo. And then we're creating another function inside namespace foo, which calls print, and then which calls print the global namespace. Then we're calling print the foo with the scope resolution operator, and then we're calling print hello there. So if an identifier inside a namespace is used with no scope resolution, if an identifier inside a namespace is used and no scope resolution is provided, aka just the compiler will first try to find a matching declaration in that same namespace. If there is no match, the compiler will then check each containing namespace in the sequence, i.e. lines of code, sequence to see if a match is found, with the global namespace being checked last. Okay, being checked last. Um, in the above example, print is called with no namespace. Because print is inside foo, the compiler checks to see if the declaration foo can be found. Since foo print exists, it is called. Yes, that makes sense. If foo had not been found, the compiler would have checked the containing namespace. Note that we also made use of the scope resolution operator with no namespace to explicitly call the global. Yes. Forward declaration of content and in namespaces. How are we looking here? Okay, we can continue. The time is okay. Perhaps we'll continue with this and see where we are at the end of this. Okay, forward declaration. So remember that the syntax for header files and forward declarations is if not defined, name and then the header, some unique name here, then define some name here, and then you'll do some code here, aka the forward declaration, and then we'll do end if our some unique name is not defined, then we'll define it, then we'll do a bunch of stuff, and we'll end if. Identifies inside a namespace. So when dealing with namespaces and forward declarations, the identifiers inside a namespace who contain a forward declaration also need to be inside the same namespace. So for example, a header, add header, and it would be if not defined, add h, then we will define add h here. Then we'll do the name space basic maths, and then within the body we will do forward declaration of an add function of int add with the parameters of, with the return type of int, name of add, identifier of add, and then parameters of int x and int y. And then as always we will, with a forward declaration, we will end if. Then in our add CPP we will want to include add h, and because it's our own one we would do add h. Then we need to include the namespace again, basic maths, and then this time we want to define the add. So it would be return type of integer, add with the parameters of integer of x and y, and we will be returning x plus y. Yeah. And then in our main CPP we would again, as always, include add h, and then the return type of integer for our main function. And then standard character output, and we would do basic maths, and we would use the separator identifier. That is the word, right? Resolution operator, sorry. Resolution operator, and we would do add on 1 and 1. And then as always in main we will return 0. Okay, so then what we'll do is if the forward declaration for add wasn't placed inside the namespace basic math, i.e. here, then add would be declared in the global namespace instead, and the compiler would complain that we didn't have a declaration because there is no add anywhere in our global namespace. So that's why we would get an error there. And the compiler would complain that we haven't seen a declaration, correct? If the definition for function add wasn't inside basic maths, if the definition, so now we're here, if the definition wasn't inside basic maths, um, the linker would complain, yeah, because there is no such thing as add. So here is the definition, and here is the forward declaration. Yes. So we'll just leave that note there. So multiple. So what's the time? So we've been going for about 2.5, and I think we could finish that today. Okay, let's have a look where we're at. So we'll get rid of that. We will do that. So multiple namespace blocks are allowed. So namespace basic maths, constant expression, double pi, 3.14. Ah, okay. So multiple namespaces of blocks are allowed. It is fine to declare namespace blocks in multiple locations, and by define they mean something like this, rather than declaration, which would be something like this. All declarations within the namespace are considered part of the namespace. All declarations within the namespace are considered part of the namespace. So, for example, here we have a header. If not defined, circle header, define it. We have a namespace of basic math. We have a constant expression of a double pi, a 3.14, and we're ending there. Then we have growth, and we're again creating a namespace of basic math, and we're doing a double of e. So even though we've used basic math, we've defined basic math here and here, they will all be lumped together, i.e. it's as if you just did this in here. And then you would need to call, obviously, the headers of growth and circle. And then you can call basic math pi and basic math e. But surely I would think that you would need to, or want to, you would want to make sure that your code is neat and everything, and you wouldn't actually want to do that. You would just want to, I mean, I personally would just include this in this. But it's still there and it's still possible. So what I'm going to do is I'm going to do for an example, and then we'll do circle H, growth H, main CPP, and then I'll just copy and paste those. And then in our main, we'll obviously call those there. Whoops. So the standard library makes extensive use of this feature. Yeah. Do not add custom functionality to the standard namespace. Okay. Nested namespaces. Nested namespaces can be nested inside other namespaces. So I assume then you would do foo, then the what's it called? Separator identifier, resolution operator, scope resolution, operator. You would do foo dot dot, yeah, goo, exactly. Nested nested namespaces are also allowed. It is possible to nest namespaces inside other namespaces. Yes. Okay. Namespace aliases. Because typing out the qualified name of a variable or function in a nested namespace can be painful, C++ allows for namespace aliases, which allow for us to temporarily shorten a long sequence of namespaces into something shorter. So namespace foo. Okay, so you're just calling and giving it a new value. Yeah. That makes sense. Namespace aliases. One nice advantage of namespace aliases is if you want to move the functionality of within foo to a different place, you can just update active alias to reflect the new destination rather than having to find every instance of foo. Okay. If you want to move the functionality within foo to a different place, you can just update alias to reflect. Okay, yeah, that makes sense. So we've moved the declaration, let's say the definition of this add function into v2, and then we've done namespace. But remember, the namespace, to make sure it's possible, we need to allocate or declare foo with the namespace identifier. Okay. That makes sense. And the final, how to use namespaces. How to use namespace aliases. It's worth noting that they were designed primarily as a mechanism for preventing name collisions. So smaller applications developed for your own use typically do not need to be placed with namespaces. However, for large personal projects that include lots of third libraries, including namespacing your code can help prevent naming collisions. And I want to make that clearer. So I'll do that. Any code that will be distributed to others should be definitely namespaced to prevent naming conflicts with your code integrated into. Often a single level namespace will suffice, such as foo logger, i.e. logging the foo. As an additional advantage, placing library code inside a namespace allows the user to see the contents of the library by using the editor's autocomplete suggestion. If you type in foo logger, autocomplete will show you the names inside foo logger. In multiple team organizations, to prevent conflict generated between different teams, these often take the form of the following: a project or a library module, a company or an organization project. Yeah. Using module level namespaces can help separate code that may be reusable later for a specific code that will not be reusable. So basically, you're creating like a code base, I assume. For example, physics and math function couldn't go into one namespace naming math. Language and localization functions in another lang. However, directory structures, i.e. folders, for those of you who don't know, can also be used for this with that specific code for project directory tree and reusable code in a separate shared directory tree. In general, you should avoid deeply nested. Yes, I agree. So, local variables. So where are we in terms of scope, definition, and linkages? So we are at 7.2, and we're doing, next we got local variables, global variables, and all these. Okay. And then we got nice control flow, and then we got error handling, detection, type conversion, function overloads, constant functions, which is what we did a bit, references and pointers, which is a big thing in C++, enums and structs, again, compound types, classes again, dynamic arrays, vectors, algorithms and functions, and operators, and inheritance, and temperate. Okay, so there are 28 functions. So we're looking at probably another 2 or 3 weeks, I would say, potentially. But that's all to look forward to. So we just finished that, or am I thinking about something else? Yeah, we've just finished. So now local variables. So I am going to stop here because we've been going for quite a long time. So I'm going to make a note of what we did. So day 12, part 2. And then what did we do? We did compound statements, aka blocks, aka We did user defined name spaces, accessing the name space through the use of the scope operator, accessing global namespaces with scope operator and through no prefix. Identifier resolution from within a namespace. Forward declaration within a namespace, and I'm just going to remind myself that I need to do if not define some name, then we define some name, and then some code here, and then we do end if. Cool. We do that. Multiple name spaces are allowed. We did nested name spaces. And then finally we did namespace aliases, i.e. allowing us to redefine or reallocate to another namespace, and then if you've done namespace identifier, then it's all good. I.e. you've done namespace identifier, and then as long as you move this to v2 as you do here, i.e. we did namespace active v2 and we moved the declaration of int add into namespace v2, but because we've created the namespace alias of active, we can just change foo goo to v2. Cool. Yeah. And I just realized I need to actually copy and paste that in because I haven't. So, hang on a minute. Namespace. Oh, I already have. My bad. Okay. So that's it. The date is the 10th of August. We'll commit that. We'll clear that. We'll get rid of our Explorer. Cool. So hopefully you've enjoyed, and hopefully you're continuing to enjoy C++ and learning with me. Let me just change it to 7.2, 7.3, so we know where we are. So left off at 7.3 local variables, which we've done before, so hopefully it shouldn't be too bad. So yeah, if you enjoyed, tell me what you enjoyed. If you didn't enjoy, tell me what you didn't enjoy and what I can improve on. And yeah, I'll see you in the next one. Please like, subscribe, and yeah, see you in the next one. Bye.